Hello, welcome to the video. In this lesson, we're looking at section 11.3, where we're going to find areas of polygons. We're going to kind of dive into some formulas of specific polygons, and also we're going to look at more specifically areas of regular polygons. So for starters, the first thing we're going to look at is being able to discover the area of a rhombus or kite. So essentially, if you are given the value or values, I'm sorry, of each diagonal of a rhombus or a kite, the formulas are essentially the same. It is going to be 1/2 times it by one diagonal and times it by the other diagonal. So looking at these two examples, A and B, we are given the values of each diagonal. So for the first one, it's a rhombus. It's got 4 congruent sides. But since we have each diagonal, it's going to be 1/2 times by 8 times by 6. You multiply them all together, it's going to be 24 square meters. Looking the same thing for the kite. For example B, same thing. 1/2 times it by 7 times it by 10, which is going to give us 35 square centimeters. All right, relatively straightforward. Here, it's talking about, it says in the diagram, A, B, C, D, E, which is a regular pentagon, inscribed in circle F. They want you to find each angle measure. So what we can do is this. We need to, first off, remember what a regular polygon is. Regular polygons means that all the sides are the same and all of the angles are the same. Okay. Now, with that being said, we have some different angles here that they're asking us to find specifically. So the first one is they want us to find AFB. So they want you to find this angle here. That's the first one. Well, in order to get to that point, I need to figure out what this angle is here. So like what this angle is here and like what this angle is here, because that's going to help us figure out the rest of the unknowns. So if you recall, the sum of all the interior angles of a polygon with 5 sides is going to be 5 minus 2 times it by 180, which is going to be equal to 540. And then to get each individual angle, I'm going to divide that by 5, which then gives me 108 degrees. So all of these are 108 degrees. Now, what we have here is that this angle here is cut in half. So essentially, if I took 108 and divided it by 2, I would get 54. So this right here is 54. So to find this angle right here, because it's a right triangle, I can say 180 minus 90 minus 54, which is 36. So right here is 36 degrees. Well, they want you to find this measurement right here, which is going to be twice as much as 36. It's going to be 36 times it by 2, which is 72 degrees. Next, they want us to find AFG. Well, we just found that because we know it's half of 72, so it's 36 degrees, which we already found. And then the last one here is GAF, which we found that one. That one was half of the 108 degrees, which is 54 degrees. So again, once you figured out this one piece of information, all of the other pieces of information just kind of fell into play. All right, so this formula here is talking about finding the area of a regular polygon. So that can be, you know, the pentagon that we just looked at in the previous slide, hexagon, octagon, anything that's regular, anything that the sides are the same and the interior angles are the same as well. This is the formula that they are asking us to use. It's going to be 1/2 times it by A. A is called the apothem. The apothem is the distance from the center of our regular polygon, and it is essentially, it's an altitude from the center to a midpoint on a side, essentially, which then makes it a 9-degree angle, and then it's going to be times it by capital P. P is the perimeter of that said regular polygon. So you need to find the perimeter of that is. So it's going to be whatever that value of S is, times it by N. N is the number of sides of that regular polygon. So there are some possible trigonomic concepts that might be needed in order to find these things. But we'll take a look at some examples and see what we come up with. So for question 5 here, it says they want you to find the area of the regular polygon. So again, it's 1/2 times it by the apothem times by the perimeter. Do we have the apothem? The answer is yes, that's 6.5. Do we have the perimeter? The answer is no, because I need to know what this value is here. I don't know what that value is. But what can we do? Well, we can figure out the distance to this portion, halfway point of a side measurement, because what we are given is a right triangle. We can use the Pythagorean theorem to help us out. A squared plus B squared is equal to C squared. We don't know, let's say we don't know what A is, but we know that B squared is 6.5 squared, which is what, 40, whoops, try that again, 42.25, and 8 squared is 64 because that's the hypotenuse. So I'll subtract that 42.25, which gets us 21.75, which means that A is going to be 4.67, which tells us that the side measurement here is going to be 4.67 times it by 2, which is 9.34. So there's 1, 2, 3, 4, 5. So times that by 5, I get 46.7. So my area is going to be 1/2 times by the apothem, which is 6.5, times by the perimeter, which is 9. I'm sorry, 46.7.
So when I multiply all that together, 0.5 times by 6.5 times by 46.7, I get, looks like a 151.8, and there's no units here, so I'm just going to say square units. All right. Looking at 6, the only thing they gave us was the side measurement of one of the regular polygons, and that's 7. So let's see how many sides there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10-sided figures. So the perimeter of this particular polygon is going to be 10 times 7, which is 70. So I got the perimeter. What we need to find now is the amphitheum. So how we're going to find that is I got the center point right here, and I need to find this value right here. Well, you might be asking yourself, all right, so how can I find that point? Well, what we need to do is we need to figure out what this angle measure is. Recalling, we can solve that by, okay, knowing that's a 10-sided figure, 10 minus 2 times it by 180 gets you a value of 1,440 for the sum of all those angles. Divide it by 10 because it's a 10-sided figure. So this particular one is 144 degrees. Now, cutting this in half, that means that this angle right here is 72 degrees. This distance right here is 3.5. So here's what we know. I know that this is 72 degrees. X is opposite to the 72. 3.5 is adjacent. That means that I can use trig functions to help us out. So the tangent of 72 degrees is going to be equal to x over 3.5. Essentially, the amphitheum, or x in this particular instance, is going to be the tangent of 72 degrees times it by 3.5, which gets us a value of about 10.77. So found the amphitheum, I know the perimeter, I can just plug those in. So my area for this is going to be 1/2 times it by the 10.77 times it by the perimeter, which is 70. Multiply all of those together, we get a value of 376.95 square units. And that is looking at areas of polygons. Hope this helps. Until next time.